Assalamu alaikum. Okay, students, now I am going to talk about the next topic, and that is fitting of an exponential curve, and that is the third part because we have already learned that how we are going to fit a straight line. We are how we are going to fit in a second degree polynomial to the raw data, and the third is that is the important one. We are going to learn that how we are going to fit an exponential curve to a raw data. Over here, for example, if you have this general mathematical form of this exponential curve can be written in this form: y is equals to a exponential of bx. Whenever you have some exponentials involved, you just have to simply take the log of this, and by taking this log of y, that is equal to log of this whole expression, and this is appearing in the form of multiplication. So you can write, by using the property of log, you can write it in this form: log of a plus bx into log of e. Now you have to be careful that this is not this is simply as log of e, this is not ln of e, right? Because we are taking this logarithm over here. Now what I will do, I will just resubstitute these log values in the form of capital Y, because it is involving this variable. There is no variable, I can write it as capital A, and simply there is no variable, I can write it as constant capital B. And when I will put all these values over here in this equation, you can see that you will be getting capital Y is equals to capital A plus B summation B into X. Now you can see that is simply an equation of a straight line, and the equations that are needed to find the values of these two constants can be written in this form. What we will do, we will just solve these two equations and then find the values of a and b, take the anti-log, and just I will put it over here in order to get that general expression of the exponential curve, right? So you have to be very careful in this case. You can see that there is no change in x, that is a small x, but this y is a capital Y, it's not a small y, and this capital Y of course is different from small y because we are taking log of y, right? So I will just come to an example that you are given this data, and you have to estimate, you have to fit an exponential curve first of all to this data, and then you have to estimate the value of x equals to 10. You can see that at x equals to 10 there is no behavior of the function given over here, and since this 10 is lying between this range from 1 to 12, so we can use the word interpolation over here, right? This is given to you that the data point, whatever the values you will be getting, finally those values should be correct to 4 decimal places. This is very important because of course exponential is involved over here, and you have to first fix your calculator to 4 decimal places, right? So if you want to fit an exponential curve, then you have these equations: capital Y is equals to capital A plus B summation B into X. And what is the value of capital Y, capital A, and capital B? You just write it over here. And I want to solve these two equations. Now I see what I will do. First of all, x or y I will just make a column of this. Now the first thing is that I have to sum up these values. There's no need of sum of y values because you will be needing this capital Y. You have to form capital Y, and this capital Y is equals to log of y. Take the log of 10, then write it over here. Take the log of 15, write it over here. And you can see you have to fix your calculator to 4 dp first. And with the help of that, you will be getting a very confined answer, right? There are no unlimited decimals involved over here, points, right? So when you do that, you have to you can see that over here you will be needing this column sum of capital Y, and I can have this from here, and n is the data points, 1 2 3 4 5 data points, and the value of n will be equals to 5. And then sum of x column, you can have this from here, and then sum of x into capital Y. There's no x into small y, but you have to multiply this x, the corresponding value of this x, with capital Y. Respectively, this 5 into this, 7 into this, and you just have to make this column. And by summing, you will be getting these values. And then see, you will be needing x square. So make these values square and write it over here. Make the sum and just insert it in these values. You can see that over here I have inserted these values, and I have these two unknown constants, capital A and capital B, and I have two equations. So I can simply find the values of capital A and capital B in this form. So now what was capital A? Capital A is equal to log of A. So if I have to find the value of this small a, then I can just simply take the anti-log of this, and you can see that A is equal to anti-log of this, and you will be getting the value of this, right? And in some calculators you may be getting this value, so you don't have to get worried, okay? And what is B? You can see the small b is equal to capital B over log of E. You don't have to take the anti-log over here in this case. So you can see that the value of capital B that I have calculated is over here, and log of E, if you just simply write it from your calculator, it would be of this form up to 4 decimal places, and you will be getting the value of this. You can have this up to 4 dB, right? So your main task was to find the values of small a and small b, and you have done that. And you can simply write this equation, because you can see over here that is y is equals to a into e power bx. Just put in the values of small a, small b over here, and you will get the required exponential curve, right? Now they were saying that you have to estimate the value of x is equals to 10. When x equals to 10, what would be the behavior of y? You have to interpolate it. You just have this mathematical form that is now helpful in estimating or interpolating or extrapolating the values of the unknown function points. You can just put it over here 10, and you will be getting the value over here, right? So the question that you are going to do, that you just have to fit an exponential curve and to this data, and you make sure your calculator should be fixed to 4 decimal places, and the answer that you will be getting will be y is equals to this 0.5580 e power 1.0631x. I have mentioned these answers over here. You just have to solve this question for your practice, and of course you can have so many questions on the Google as well for your practice. You just do those. If you have any queries, if you see that you cannot you're not getting any point, just WhatsApp me, and then I will answer you after listening to your queries, right? Okay, thank you.